Okay, so armed with our vertex formula to get standard form, let's go ahead and practice it. We found that the x-coordinate of our vertex is given by the formula negative b over 2a. And then what I shared with you to find our y-coordinate k, I actually like to plug this value into my function. All right, and that's the way that I prefer to find k, although you could use that other formula. So what we have here are three quadratics in general form. We're going to find the vertex and put it in standard form by following our vertex formula. And just as a comparison, we've already done these three. There's the same three quadratics that we did with the modified completing the square. So we're going to be doing the same thing. So we're expecting 2, 5 as our vertex, 6, negative 11 as our vertex, and 1/3, 2/3 our vertex. So let's see if we get what we're supposed to get. So finding the vertex for this first one, again my h coordinate is negative b over 2a, and so plugging in what I know, we got negative 8 over 2 times negative 2. This becomes negative 8 over negative 4, and we get 2. So h is 2. So far, so good. How do I find my k coordinate? You can use that crazy formula we got in the last video, or you can just simply substitute, right, that x coordinate into the function to find your y coordinate, and I'm going to choose to do that. So working here, plugging that in, 2 squared is 4 times a negative 2 is negative 8. That's a 16 minus 3. Going left to right, we have 8, take away 3, and we get 5. So there's my k. So where's my vertex at? My vertex is at 2, 5. My a is equal to negative 2, right? It was always that lead coefficient. So if I wanted to put this in standard form, it would be f of x equals negative 2 x minus 2 squared and then plus 5. All right, which is exactly what we got when we did it the old-fashioned way, completing the square. So we got something that works. The next one, again, to find the vertex, what we're looking for is my x-coordinate h is given by negative b over 2a. So plugging in what I know, my b, we have a negative 3, and we're taking 2 times 1/4. So this becomes positive 3. 2 times 1/4 is, there's a cancellation there, we end up with 1/2. And we've learned that when I divide by a fraction, it's the same thing as multiplying by the reciprocal. So what we get is that h is 6. So there's our x-coordinate of our vertex. How do I find the y-coordinate k? Well, I choose to take the, oops, it's g now. I choose to take my function and put the input into it, the x-coordinate. So we get 1/4, 6 squared, minus 3 times 6, minus 2. And this will be 1/4 times 36. That's negative 18 minus 2. 1/4 of 36 is 9. Minus 18 minus 2 is 20. And then 9 take away 20, that gives us negative 11. So there's your k coordinate. So my vertex is sitting at 6, negative 11. And we knew that our a was 1/4. So, right, that's the lead coefficient. So my, dang it. So my standard form is 1/4 x minus 6 squared minus 11, which again is exactly what we got when we did it the completing the square way. So we got something that definitely works with maybe half the work. Okay, last example of using this, our vertex again, and again I think as I look at this, maybe I shouldn't call this h. This h, that's the function, is different than this h, that's the coordinate of our vertex. So I apologize for that. I'm kind of over abusing some language there, but my x-coordinate, my vertex h, is negative b over 2a. So plugging what I know, I have negative 2, let me write that better, negative 2 all over 2 times 3. Well, the opposite of negative 2 is 2, and 2 times 3 is 6. What we get is 1/3. So there's my h coordinate of my vertex. How do I find my k coordinate? I basically evaluate my function at the input that I have. And again, This h is the function name now. So we get 3 times 1/3 squared minus 2 times 1/3 and then plus 1. So this is 3 times 1/9. That's a minus 2/3 plus 1. This is 1/3 minus 2/3 plus 1. When I add or subtract those, I get 1/3, negative 1/3, and then 1, well, that's 3 over 3. And so we get 2/3. And so there's our k. So our vertex is sitting at 1/3, 2/3. Our a is equal to 3. So my standard form here would be 3x minus 1/3 squared plus 2/3, which again, just to verify, that's exactly what we got when we completed the square. So we got two ways to do the same thing. Of course, I believe, and I'm actually partial to it too, the vertex formula is obviously much easier to use. It's a nice formula, but make sure for those going on to calculus or some college algebra, please make sure you understand that process because you will see it. Alrighty, so how about we wrap things up? We got one more video to cut for 11.7, and then we are officially done.